Welcome to the law of large numbers. Law of large numbers. What are we talking about with the law of large numbers? In the previous video, we looked at experiments that went from flipping a coin once to flipping a coin 100 times to flipping a coin 1,000 times to 10,000 times. And the reason I showed you that video was to model the behavior of long run predictability, or law is kind of an intense word. I might say, the pattern of large numbers, or what happens when we have large numbers. As we increase the sample size, we gain more consistency as to what our proportion or expected percentage is, right? So when we flip a coin, we expect to get 50% heads. In the short term, we'd be naive to expect that because it's too variable. In fact, in just one flip, you don't even have the option of getting 50% heads. It's either 100% or zero. It doesn't really start to show that percentage consistently until we get to a large enough number, a large enough sample size. And then notice it kind of plateaus off. And it really, I think this is telling in that once you reach a certain level, you don't have to, this is creating a lot more work for yourself, right? Where I have to gather 900 times to flip a coin, and I'm getting pretty much the same results as when I got 100. So you can stop right there. That's the law of large numbers. So let's ask ourselves this question in trying to describe what randomness is. And we talk about randomness and chance, or randomness and probability. It means a couple things. It means that in the short term, it's not predictable. However, in the long term, I wouldn't say it's predictable, but it produces a pattern that can be used to predict. Okay, so randomness, just like chance, is everything is applied to the long run. Okay, and the reality of these two situations, the reason I preface this scenario with that talk about randomness is that we are talking about something that we'll say in theory is very, very long term. To have 3 children is a lifetime, is a responsibility, is juggling a lot of different things. In the statistical world, 3 times, 3 events is very, very, very small. So our results in this experiment might not be true to what actually really does happen in the long term. But we're going to test this theory of randomness and independence in this scenario right here. So what's more likely, having 3 children in the order of boy, boy, girl, or having 3 children in the order of boy, girl, boy? And we're assuming here that the likelihood of getting a boy is the same as a girl. So we're going to use the website to flip a coin and get heads or tails to simulate this. So in random.org, you can go to this tab here for games, and there should be an option for a coin flipper, a very fun game. For 3 children, we're going to flip 3 coins, and let's use something that we're probably familiar with. Let's just use the US penny. Okay, and we're going to flip those coins, and let's test let's go back to the experiment here real quick. So we're going to test boy, boy, girl, and then boy, girl, boy. All right, and we're going to say girls are heads and boys are tails. Let's see what we get. All right, in the first one, we got boy, girl, boy. Boy, girl, boy. Okay, looks like it happened first. Okay, let's keep going. Here we got girl, boy, boy. All right. Girl, girl, boy. All right. All boys. All girls. And then here, I believe, we have boy, girl, boy again. So far, it looks like this one is more realistic, right? We have not gotten 2 boys and a girl. Not yet. All right. We'll keep going. All right. Again, all boys. And I think we got boy, girl, boy again. So in about 20 opportunities, okay, I'm going to stop it there. in about 20 opportunities, we had this opportunity 3 times, right? We had this opportunity 0 times. So if you are thinking like me that this is more likely, in the short term, I would agree with you. But statistically, it tells us that they're both equal. These opportunities are equal. If you were to evaluate, another way to think about this is if you were to evaluate, say, 1,000 different families in your town or 1,000 different communities where all of those families met the same criteria, that they had 3 children and they had 2 boys and 1 girl, you should notice an equal breakdown between the families that have boy, boy, girl, right? The oldest is a boy, the middle child's a boy, the last child is a girl, versus the firstborn and the youngest being a boy and the middle being a girl. All right. It's tough to model that in the short term because I want to value your time. I'm not going to do a video that has this occur 1,000 times, but if we did it 1,000 times, and if you had the time to do it 1,000 times, you would notice that these 2 outcomes in the long run will happen at the same frequency. Okay. Again, that, my friends, is the law of large numbers. What we just did in that experiment, was that a large number? Not at all. Okay. It was only 20. Again, I'm just using that number as a ballpark estimate. It was about 20 times.